So in this video, we will see what is a push-down automata. So in the first unit, we saw what is finite state machines, okay, and regular languages. The regular languages are accepted by finite state machines, whereas push-down automata accepts context-free languages. We saw what is a context-free language, context-free grammar in unit 2. So push-down automata is your unit 3. So push-down automata, as I said, is to implement context-free grammar, right? Why do we go for push-down automata anyway? So your FSM has a very limited memory, right? So it cannot accept uh, languages that needs storage. For example, a power n, b power n. In this example, the FSM should keep count of the value n in order to repeat it for B, right? So such kind of problems are not accepted by FSM, whereas push-down automata can accept these kind of languages because of its memory. Okay, so push PDA is just a FSM, that is finite state machine plus stack. Okay, so PDA has three components. PDA has mainly three components. One is your input tape, which gets the input. Okay, this is your input tape. Then second one is your finite control unit. Then third one is your infinite stack. Okay, so here this input tape takes the input and sends it to the finite finite control unit. Finite control unit. Okay. So this finite control unit, based on the logic, puts it in the stack, whether it's a push or pop. Push or pop. So once the final state or acceptance is reached, okay, it will give you the result whether the string is accepted or rejected based on the operations that you perform in the stack. Okay. Formal definition, we'll see. This is just an informal definition of what is a push-down automata. Let's see what is the formal definition. See, like FSM is a 5-tuple automata, right? Same FSM. Whereas PDA is a 7-tuple automata. 7-tuple automata. What are they? It has Q, sigma, tau, delta, Q naught, Z naught, and F. So here you already know what is Q, finite set of states. Okay, epsilon, sigma also you know, which is input alphabet. Tau is your stack symbol. Okay, stack symbol. Delta also you know, transition function. Q naught is initial state. Z naught is your stack's initial state. Okay, stack initial state. Then F is your obviously final state. Okay, F belongs to Q and Z naught belongs to tau. Okay, now we will see the basic operations of stack. What are all the basic operations that you know already? Operations of stack, push and pop, right? Push and pop. One more extra operation that we have in PDA is skip or read. Okay, let's see what is what. Okay, one is push. So push is basically you're pushing something into the stack. Say for example, your input tape has inputs A and B. So in PDA, your stack will always have a stack initial variable, that is Z0, and your end of the string is denoted by epsilon. So in all the programming languages, you have backslash 0 to indicate that the string has ended, right? So same way in pushdown automata also you have epsilon to indicate that the string has ended. And your stack is not empty, your stack will always have initial variable z0. So now your input is A, you're going to push A into the stack, right? So how will you write a transition function for this? Let me say that. Okay. First, the template is your initial state, say Q naught. Okay. Not the initial state, the state which you are in now. Okay. Your input is A and the stack initial symbol is A. Z naught, sorry, Z naught equal to, okay, the state that you have moved into now, that is Q naught. And what is the current state of your stack? A Z naught. Okay. For push, you don't change the state. You write the same state that you are in already. Okay. So how will you? So the template is state, comma input, comma initial stack variable. Initial stack or current status of stack. Okay. Here, the state you moved on to for push again, I'm saying for push, you don't have to change the state. Okay. And A Z naught is your state of stack after adding the input. After adding input. Okay, hope you understood. How will you draw the PDA for this? Okay, you are in state Q naught. So you are not changing any state, which means it is a self loop. So the template for writing the transition is, okay. So you can write this like this also, right? Q naught tends to Q naught, which indirectly means it is a self loop, right? So A, your input symbol, comma Z naught. Z naught is your initial, I mean, before adding the input, state of your stack before adding the input slash A Z naught, state of your stack after adding the input. This is before and this is after, and this is your input. So this is how you draw the PDF for push operation. You can mention it here itself. Okay, now let us see how would you write for a pop operation. So say you have a input tape with inputs B and C. Okay, you want to so you already have Z naught in the stack. Okay, you have pushed B. Now you have a C. So the logic is in assume that the logic is for every C you need to pop a B. So C is coming, so you have to pop a B. So how will you write the transition for that? Delta of your in state say Q naught, comma, the input that is arriving is C, the state of your stack is BZ naught, right? The state of your stack before adding the input is BZ naught equal to Q1. For pop operation, you change the state only for the first pop operation. Okay, for the second pop operation, the state remains the same. Okay, if you change the state to Q1, the next pop operation will also have Q1 only. That's only if the next symbol is also B. All right. So, comma epsilon. Here you don't have to write the state of the stack after adding the input. Okay. Because for all the pop operations, the second value should be epsilon only. So this is your current state, input, the state of the stack before adding the input. This is the state you have changed after your pop operation, and this is epsilon. For all pop operations, this second one would always be epsilon. Okay, how will you draw a PDF for this? Currently you are in Q naught. So it is a pop operation, so you are changing the state. Your input is C. Right. What is the state of the stack before C? Then epsilon. For all pop operation, this also should be epsilon. So that is pop. Now you have skip or read. Okay. So skip or read. So consider, say your input is A. Okay. So in skip or read, the name itself tells you that you just skip or like you ignore it. You neither pause, push something or pop something. The status of the stack will remain the same. Say you have that not in your stack now. So after reading this A, also it will remain the same. Understood. So how the transition would be, you're in some state called Qi. The input is A. Stack state is Z naught equal to Qi comma Z naught. The state of the stack remains the same. Okay, these are the basic three operations of PD. So from the next video, we'll see the examples for